This is again a mathematician's favorite, probably not useful. So you are required to explain why this is discontinuous and you know where it's discontinuous and why. And I'm going to make note cards in class. We're going to make them together so that we have this compiled. I wish we could do it now, but I want you to actually have cards so that you can study off of. But it's a checklist of why something is discontinuous. I'm going to go through it pictorially here, but I'm going to formalize that checklist in a minute. So I can tell you the first thing is wherever you have to pick up your pencil when you're drawing this, so start from the left. When you pick up your pencil, you are finding a point of discontinuity. So the first point is right there. I had to pick up my pencil here because I went down to hell and then I came back up again. And then here I had to pick up my pencil, and then here. And now I can write down why there is. So it says explain why. We're making you do things by hand because we want you to really explain why. So at x equals -2, the y value doesn't exist. This is a gap. It's not real. We never hardly ever see this in applications. I don't want to say never because there's probably some weird application out there, but this is a mathematician invented thing just to make a counterexample. We actually have books called Counterexamples and Examples in Real Analysis. We make books with a bunch of examples that no one else would ever think of. Here's another one. At x equals -1, y goes to -infinity. We have a vertical asymptote. At an asymptote, you have a point of discontinuity. So at x equals 0, I have what we call a jump discontinuity. I started here and I jumped down here. And so the way we use mathematics to say that is the left limit as it approaches 0, y approaches 1 on the left, and y approaches -1. I made up -1. They didn't map out the y-axis. So the left limit and the right limit don't equal each other. That's called a jump discontinuity. So I jumped from one point to the other, and therefore that's a point of discontinuity. And then x equals 1 blows it in a number of ways. The left limit and the right limit don't equal each other, so I made up numbers for it. And the left limit and the right limit don't equal the actual point value. So that's another reason that the point value at 1 is somewhere around 0.75. I don't know, I just made up numbers. So you have this like colored in dot someplace else. So it's still a jump discontinuity because you had to jump from one end to the other. So that's how you do number 4. I love these kind of problems, which is why I went into mathematics, but I also recognize that these are invented problems to kind of think of all kinds of possible counterexamples.